Okay, so here's a problem that went viral, and it was written about all over the place. I just found it on the internet on independent.co.uk. So the question was: a 50-cent coin has 12 sides of equal length. Okay, this is not in the U.S.
Yep.
Two 50-cent coins are balanced next to each other on a table so that they meet along one edge. See that?
Yep. Mm-hmm.
That's shown below. The angle X is how much? Do you see that angle in there?
Yep. Yep.
So 12, 30, 36, 60, or 72. How would we solve this problem?
Well, maybe we could look for the extra, if we found these are all regular angles, so we looked for we have the internal angles and the external angles.
Okay.
So we could look for those. So the internal angles of a regular 12-gon.
I think that's called a dodecagon.
Okay. What would they be? We just found it.
So 180 times 10.
10 minus, so 180 times 10 over 12.
Okay. How can we evaluate 180 times 10 over 12?
Well,
don't multiply.
Yeah.
So 180, so you can cancel a 3 with the 180.
Okay.
So you get 60. You get 60 times 12 over 4. I mean 60 times 10 over 4.
60 times 10 over 4. Okay, good.
So it would be...
And then cancel the 4 with the 60.
All right.
So you get 15 times 10.
Okay.
So 150.
Yep.
So the internal angles of a 12-gon are 150.
So if you can imagine drawing a straight line.
Sorry for that, I don't know.
If you can draw a straight line from here across, you're left with so angles. Actually, if you draw a straight line, angles on a straight line sum up to 180.
Okay.
Actually, would that work? Well, these two angles are 150.
Uh-huh.
So how much would this angle between them be?
Ah, good question.
Well, if you could look at this circle, because this angle is also x because of symmetry.
All right.
So if you drew like a circle around here, you have 450 degree angles. But that would be, no, that wouldn't work.
Okay. So we know those internal angles are 150.
50.
Okay.
So the external angles are 210. The external.
Well, like this angle here.
Yeah.
And that angle is 210.
So.
Well, maybe if we could look at this little shape that X is in.
Oh, wait. I see something.
Okay, what do you see?
So, the problem, so it looks like, so if we imagine, so X, so we have, if we continue building on X in the middle, it looks like there's going to be 1, 2, 3, 4, 5X.
What? I can't see.
So 1, 2, maybe 3, 4, maybe a fifth X.
Gosh, I don't see.
I'm not sure what you mean.
Yeah, I'm not sure what you mean.
I see that there's a second X up here.
Yeah.
But.
Where's another one that you see?
So maybe building on to this X here.
Don't know if you can do that.
Yeah, I'm not sure. We need some idea to figure out what X is there. But what do we know already?
We know that the internal angle is 150 and the external angle is 210.
Yeah, so these are all 150.
Okay.
But then they're sort of stuck between these 150 degree angles.
Okay.
So what can we use? Let's see. So, well, maybe if you looked at a triangle, if you put maybe like another one of the 50-cent coins touching this one,
Okay.
it would look like there's a triangle in the middle
Yeah.
with like X. It's a regular triangle because all these sides are the same.
Okay.
So that would lead me to believe that it was 60 since the angle in a triangle out to 180.
Okay. That's an interesting approach.
Well-
Yeah.
But you're putting one here, right?
Yeah.
Yeah.
But how do you know that that side is that side?
Yeah, good. That's a very good question. We don't know for absolute sure that that side is equal to that side, but we do. That did lead you to a good guess that it looks like it's going to be 60.
Yeah.
So, is there any other way that we can see that that angle is equal to 60?
Well, what else could you do involving like equilateral triangles?
Tell you what, let's draw it out on our whiteboard.